And if you guys are interested, we can talk about it a little bit. If not, it's just a little exposure. One tool that I'm using right now is something that I have used in previous semesters. It's called Joplin, Joplin. So if you want to download this, I think it's joplinapp.org. It's basically just a tool where you can type in Markdown on the left-hand side, and it's rendered on the right-hand side. It's great for capturing notes, if you're really fast with typing and you don't mind, learning how to encode equations and mathematical notations. Um, it's really quite flexible. I like it a lot, but that's still just personal. And because my laptop computer is really a tablet, it has a stylus. So today I'm also going to experiment a little bit with Zerno. And, oh, okay, you cannot see that one. There we go. So Zerno is basically just a very basic tool to capture what I draw using a stylus. So for things that are kind of more freeform, I will put it into the Zerno screen. So it will still be recorded. Okay, so instead of putting stuff on the whiteboard, where it's difficult for you guys to capture, now it is also part of the recording. So you can actually just kind of roll back to that. And if you want to stop the frame, take a screenshot and and cut it out and put it into your own notes, right? I mean that makes it like super duper easy. All right, so those are the tools. And I sent out a email earlier today. So if you go to the announcements, some of you may not have a chance to read the announcements. That's okay. Because we are getting into some material that might be a little bit more abstract and a little bit more involved. So it's a good time to kind of practice good study skills. So I'm just going to quickly go through this because I went through this with my other class already, and I felt that it's probably useful to go through that with this class as well. All right. So historically, this is where some students start to encounter challenges, not because they are lacking in terms of intelligence. It's mostly because they did not come prepared. That's the biggest issue that I can see. So there are some actions that you can do or anyone can do to help overcome these challenges. Pre-reading the class material prior to the lecture is going to be important because then it's not going to be like new concepts. Instead, those will be concepts that you kind of have some idea already. You may not know everything that you need to know about those concepts, but at least it won't be like completely new. It makes it easier to understand the concepts when I explain it in lecture. Staying focused in lecture is important also. Ask questions, okay? This is something that I learned just yesterday, okay? Somebody was doing the lab, and from the conversation with that person during the lab time, that person did not understand the concepts during the lecture, like not understanding. But yet, there was no question during the lecture. No one raised their hand and go like, okay, Tech, but I'm not quite understanding what this equation is for. What is the purpose of this equation? What are we given with and what are we deriving? Okay, so it may not be clear, okay, even though I try to be clear in my written material, but if it's not clear to you, the purpose of the equations or the purpose of the formulae, raise your hand, ask those questions. And obviously, taking notes is going to be important too, because one thing it does for you is to help you focus. Because when you're taking notes, especially when you're trying to paraphrase or write down what your thoughts are on a piece of paper or on the computer or on the tablet, you are focusing. Okay, so it really helps you to focus in the class. And then after the class, it is important to post-read the material. That's including my material. It's also including your own notes. And because I give you the recording of the lecture as well, that is also available. I mean, rewatching the entire 80 minutes is too much. Okay, there's no need most of the time to reread the entire thing. However, if you find certain sections like, okay, I'm not quite sure what that section is about, or I need to watch it again, you can just rewind the tape and watch that part again. Um, and this part is for people who might find reading the material challenging. We do have a RAD program. RAD stands for Reading Across Disciplines. So they will teach techniques to take notes, techniques to read technical documents, which is basically all the documents that I write here for you guys. Um, So this class is taught assuming the written material linked from Canvas is read and understood. So that's a really big assumption on my part, but that's what taking a college class is about, okay? So there's no way around that one. The STEM home base is right there, okay? If you walk out this door, make a left turn, and just go straight down, that's the STEM home base. So the STEM home base is another resource because I think they might have tutoring, they might have counselors and coaches to kind of help you navigate through classes. So I just want to make sure that these resources are advertised and you guys are aware of that. I'm not saying that you guys will need it. I'm just saying that if you need it, it is there. All right, so we are now going back to base conversion, okay, because that's where we left off last time. And if I remember correctly, I kind of recommended all of you to read and finish this particular module. Is that correct? Think so. Okay. All right. So what we're going to do now is to formally go through this, module here, and I really hope everybody had a chance to read the entire module, even if you find certain sections to be, I'm not really sure what this means, or I'm kind of confused about that symbol, but have it at least to read through the entire thing once. Okay, that is really important. Some people can't absorb everything just from the lecture, okay? It's possible. But nonetheless, it is important to kind of read it on your own first. All right, so we're going to start with section 4, which is basically starting off with something that you should know already. Okay, so we have a base 10 number, 16.375, which is otherwise known as 16.375 or 16 3/8. Okay, because 3/8 is also 0.375. So I break that number up, okay, into its components. So I say 16.375 is the same thing as 10 plus 6 plus 0.3 plus 0.07 plus 0.005. I don't think that part, the first line, should be a challenge to anyone in this class. But then I look at all of those things and say, hey, 10 can be rewritten as 1 times 10 to the power of 1. 6 can be rewritten as 6 times 10 to the power of 0. 0.3 can be rewritten as 3 times 10 to the power of -1, and so on. So if the first time you read this and you're wondering in your mind, why would tech break it down and make something simpler, a lot more complex than it really should have been? Well, that's a good line of thinking. Why? Right? Because it's here for a reason. The reason is I want to show you the structure of a number. Each digit of a number is representing the quantity of the base raised to a certain power. But that power depends on the positioning of the digit itself. That is what I want to show you. For instance, okay, let's take a look at the 6, okay? The 6 is representing, the quantity of 10 to the power of 0. Why is it 10 to the power of 0 and not 7 to the power of 0? Because it's a base 10 number. So the 10, the base, determines what you're raising a power from, and then the position of the digit tells you, how much to raise the power to. Okay, so that is the structure. Do we have any questions about either of these lines? But do we see a structure? Do we see a structure of how a number is representing a value? Okay, all right. And do we see, the only part that has to do with base 10 is we are raising 10 to the power 1, 10 to the power 0, 10 to the power of -1. That is the only part that is dependent on what base we're using. So we can change it to base 7, we can change it to base 5, base 2, base 16, whatever. Are we still doing okay so far with this? Okay, so this is more or less a formalization of what we talked about last Thursday. Okay, now if anyone is thinking, I cannot remember what we talked about on Thursday, then I'm going to have to talk to these people after class about study skills, okay? Because it is important that we do not lose track. I know 4 days has passed, okay? But it is important to, before class, to kind of bring yourself up to speed with what we talked about in the prior class. All right. So this is one thing that I usually do, not only with this class, but also with all of my classes. So I'm going to do the abstraction here, okay? In other words, these two lines are very specific to base 10 and this particular value. So now you say, okay, what if we're dealing with a different number, okay? You know, can we extract the pattern? Can we extract the structure? And just kind of focus and indicate what the structure is about. So this paragraph here is explaining what is d subscript I. D subscript I is a digit of a number at position I. Sounds pretty simple, right? Except I can be -1, -2, and so on. So if you look at the original example, this would be D0 because it is the digit corresponding to 10 raised to the power of 0. This is D1 because it is corresponding to the quantity of 10 to the power of 1. So those are non-negative powers. What about the 5 over here? Well, that 5 is corresponding to the quantity of 10 to the power of, it's right there, -3. So I would be -3 in the case of the 5. So this 5 here, which is a concrete example, it would have been d subscript -3 using the other notation that is described in this paragraph. Yep.
Wait, so the 6 is d sub 0 and the 1 is d sub 1, right? In this case.
Yes. Yep, exactly. So that's a very good question. You know, it's a confirmation of, okay, if I'm understanding this concept correctly, is the following true? Okay, so those are very good questions to ask in a class because it helps to verify that your understanding is correct. Okay, so anytime you have any doubt of, I'm not really sure, but I think this is what you're saying, you know, ask those questions, ask for a confirmation. All right, excellent. All right, so next. So what we're going to do now is to say, okay, any number is made out of a bunch of digits. So D0, D1, D -1, D -2, D2, D3. It's not in any particular order in this case. Those are the digits of a number. Okay? And in this case, because we're assuming that we're dealing with base 10 numbers, so they're all corresponding to 10 to the power of something. And that something corresponds to the position of the digit. And it's just a huge summation of all of these things that makes up the value being represented by a number. And as a result, we have this notation here. So are we all familiar with the sigma notation, or does anyone want me to kind of explain what sigma is about? All right, so I'll go ahead and explain the sigma notation. And anytime you want to find out, how this is typed, okay, this is something that's kind of cool too, is you can right-click, show math as, and then go to text command. And this will give you an idea of how it is typed. And then the other thing you can do with this is to go to Joplin, and you can actually paste it here with $2 as delimiters, and then paste exactly that code here. And this one doesn't like it because it doesn't handle align. Okay, that's unfortunate because that means I cannot just copy and paste the entire thing. I can still do a portion of it. So I can just do this portion and get rid of the beginning. There we go. So now we have this notation, and I want to show you what it is representing. So if I were to look at this and say, okay, what is the value, what is the resulting value of this entire thing? This is the kind of code that I would write in C. So this is a block of C code in Markdown. And then what we do is we just say, I guess, double sum equals to 0. Because I need to initialize the sum to be 0 to begin with. And then I have a loop. So the loop is going to say for unsigned I equals to, oh, actually, I want to change this a little bit. So instead of using infinity or negative infinity to infinity, I'm just going to change it to a to b. So I'm using ab to identify where do we start and where do we end. So now we initialize I, which is an index variable, to a. And as long as I is less than or equal to b, we continue the loop. And then with each iteration, we increment I. And in the loop itself, the only thing we're going to do is to say sum plus equal to f of I. Yes, I have not changed the other one to also refer to f of I. So this is going to be changed to f of I, which is just some function that depends on I, and it gives you a double as a result. So let me just double check. Yep, I think this is sufficient, and we'll just go ahead. I will go ahead and put a comment here and say your sum is the result of the entire operation. So is that helping to explain what the sigma notation is representing? It really is just saying starting with I equals to A, stopping with I equals to B, and I just increments one by one. Evaluate whatever f of I is. Okay, so f of I can be something simple, like just I itself. It can also be something like what we have been talking about, which is d subscript of I times 10 to the power of I. So it can be something complex, it can be something simple, but it depends on I itself. And then for each iteration, we are just computing the f value of I for that particular iteration, and then we add the result of f of I to the sum, which gives which was initialized to 0. And that's it. That's what the sigma notation is trying to express. It's a mathematical symbol, used not only in computer science, it's used in math classes a lot as well. All right, so are we doing okay with this explanation of the sigma notation? Okay, all right. So getting back to the notes again, and let me get rid of this window. There we go. So do we have any, okay, so let me ask you this question because I was mentioning that earlier. So if you look at this equation here, forget about the intermediate form and just look at B and look at the sigma notation. What do you think is given to you and what we are trying to figure out in this particular equation? What do you think would be the givens?
Given B.
No, we are not given B. If you read the sentence, okay, in computer programming, okay, so I'm starting with here. In computer programming, when we see a pattern, it means the concept can be represented in a concise, abstract way. In this case, okay, starting with that, in this case, given a number has di as the ith digit, then the value b represented by the number is as follows. So is that giving you a clue of what is given, what you're provided with, and what we're trying to figure out based on what is already given to you? Yep.
Is the value D and I?
Sorry?
Is it D and I? What are those two?
The
Like the number D and then the I.
But each D is not an entire number. So each D or D of something is a digit of a number. But go ahead. You're given the base, okay, very good. But in this case, the base is assumed to be 10. But what else is given to you? Just the sentence alone tells you, in this case, given that a number has di as the ith digit. So you are given a number in base 10 and all the digits that you need. Okay? And what we're trying to figure out, then the value b represented by the number is b equals to this whole thing here. So that's how you read the material that is given to you. I'm not sure whether this is confusing or not, because a lot of people say that I have a talent of making things confusing. I'm not so sure because I have been told exactly the opposite as well. So I have no idea whether my writing is confusing or not. But the purpose, okay, of this particular section of the notes is to say if you are given a base 10 number, this is how we figure out the value represented by the number. Are we good so far? Yes? Okay. Now, would you ever need to do this for base 10 number? The answer is probably not, because we are used to base 10 numbers already. We know exactly what 16.375 is representing as a value. So the idea is, okay, what about in some other bases? So when you want to generalize this equation to some other bases, this is the answer. So we can see the only change is instead of saying raising 10 to the power of I, it is raising b to the power of I. So now the question is, what exactly is b? Tack, you never told us what b is. Well, that's because I was counting on you guys reading the material ahead of time. Because if you did, then you would have understood that to use an arbitrary base b for a number representing a value v, then the following is true. So b is just a placeholder of the base. Last week, we worked with base 7, remember? So in that case, b would be 7, and then the d of i's would be representing each individual digit in the number in base 7. Is that okay or not? We do okay? Yep, all right. Now we're moving on. So this is the part where I really missed, in online teaching, because in online teaching, even though I taught synchronously, most people did not sign in, with a picture. So, I would just ask that question. Are we ready to move on? Are we all getting this? And then there's silence. So I have a little electronic device that can play the cricket sound. So after 5 seconds of no response whatsoever, I'll play the cricket sound to remind people and say, okay, let me know whether we are ready to move on or not. They can reply, using a public chat channel and say, yes, we are ready to go. Or they can use a private channel to tell me, no, I'm not quite sure, or they can ask questions. That's one thing that's nice about online is people can use a private channel or direct message in Discord. So this way, they don't have to feel shy, and they don't have to worry about what the rest of the class has to say about asking a question in class. In reality, it's none of the business of anyone else in class. If you have a question to ask, you just ask that question. How other people think of you asking that question is up to them. Okay, don't let it bother you at all. We doing okay? All right. Because as you move on to a 4-year university, you really have to learn how to ask questions whenever you have questions. Because otherwise, those professors would go to warp speed if there are no questions. I tend to go to warp speed too. All right, so the other direction is given v as a value, and you want to convert it into a number in some base. So just the title of this section alone is already suggesting what is given to you and what we are trying to derive after following all these steps. Does that make sense? Okay? Because, I don't want to sound judging, but this is actually important, so I have to say it. Because if someone is looking at the title, converting v to a number in some base, and not really understand it is implied that v is given to you, and we are trying to get, trying to derive the number, the digits in a certain base. If that is not understood, it's a reading comprehension kind of issue, and the RAD program may be able to help. We also have many other classes on this campus that can be helpful as well. I'm just gonna say, I was once an ESL student. And I still have some issues with grammar and some other things, but I think I can, for the most part, teach classes without, big problems. So, taking ESL classes is really important. Because language is important. If you want to get a job in programming, in coding as a developer, you might think the only syntax or the only kind of grammar you need to understand is C, C++, Java, and so on. That is not true. Because most companies, most bigger companies, They want to see if you can communicate well with your peers, with your colleagues, with your supervisors, with your clients, with people that you get in contact with. So reading skills, writing skills, as well as spoken skills, they're all important. Even though you think, oh, I'm just going to be coding and nobody's going to bother me, I don't need to talk to anyone, that is not true. Okay? Unless you're a contractor working by yourself, but you still have to interact with your client. So just kind of keep that in mind, that even programmers do not work in silos in the dark, as much as you television and movies tend to depict that that's what's happening. All right, so the bottom line is this, okay? So we'll just focus on this equation here, and I'm going to copy the tag command, and so I can put it into Joplin. Okay, there we go. Put $2 around the equation, and then put it here. All right, there we go. So, what does it do? Okay. So first of all, what is given to us? How do we make use of this equation here? Well, what is the purpose of this equation? How do you know which part requires, okay, I need to know these things in order to figure that out? Just by looking at the equation without any context, how can you figure out which side is given and which side is what you're trying to figure out?
I think the left side is what we're trying to figure out.
Yep, and what prompted you to think that way? That is correct, but I want to understand your thinking process.
Well, mainly because it said in the problem, like we're converting v to a number, and so.
Okay, very good. So you're using the context of the equation, and you say, okay, the title of the section is already telling us that we're given a value, and we want to figure out the digits, okay? But even without that context, note how one side only has one single unknown, because d of I is just one single value, which is unknown. The other side has a whole bunch, right? Because this b of I is not b of I. This is b raised to the power of I, which means you need to know b, you need to know I, you also need to know b in order to figure this side. It doesn't make sense that you'll be given a single value and then you have to resolve 1, 2, and potentially 3 unknowns. It doesn't work that way, right? So from the perspective of algebra, it makes sense that it's the other way around, that you are given b, you're given I, and you're trying to figure out the subscript of I. So I'm describing a mental process to try to figure out something, even without the context, and if I were asked, how to, interpret this equation, that is how I would try to interpret it, based on, which side has a bunch of unknowns, which side only has one single unknown. So it makes sense that one side that has multiple unknowns, those unknowns are given to me. I'm just trying to figure out the value of the one single unknown on the other side of the equality. This has nothing to do with assembly language programming, but it can be helpful in almost every single STEM class that you can potentially be taking. All right, so getting back here. So now we want to figure out, okay, fine. So we need to know what is V, what is B, and what is I, and we're trying to figure out D of I. So what do those things actually mean? What is V? This goes back to the context, the description that is in the notes. So if you go, okay. So what is V? V has to be given, but what is it representing? The value that we want to convert into a number. Very good. Okay, so V is is the value being converted to a number. Okay, very good. What about B? We just talked about this.
The base.
The base, very good, is the base. And what about I?
The exponent.
Well, I is applied to d of I, so what is d of I? Is the digit at position I. Yep, exactly. So I is indicating
iteration.
which iteration in the sum, right? Yeah, but it is also telling you which position. How, when we write out a number, I is telling you the position of the digit that we're interested in. Okay, so I is the position of the digit. Very good. Okay, so let's go through an example. Okay, just so that. Yep, go ahead. We are no longer assuming a space of 10 because we want to generalize so that we can work with any base. So back to the notes, we got rid of the 10 and changed it to b up here. So it says right here, as it turns out, this is only because we implicitly use base 10 usually. This means that if we choose to use an arbitrary base b for a number representing a value, then the following is true, which is just a generalization of getting rid of a constant and turning that into a variable also. All right, so let's go ahead and try to apply this. And we say, okay, so what about when v equals to 600? The base is, let's choose some really oddball base, let's say 9, okay? And then we'll choose some digit, and we'll say, let's take a look at, let's make this even more fun. Let's take a look at something like this, and we'll try to figure out digit -2. How's that? I mean, is there a problem with this? I mean, this is the value that we start off with, and the base we want to deal with, that we want to convert to, is base 9, and the digit that I want to figure out is digit -2. So where is digit -2? What would be the position? How do you find digit -2? Yep.
So the way I like to do it, I start with the decimal.
The decimal point.
Yeah, decimal point.
Uh-huh.
And if it's negative, I move that many places in the negative direction.
On the right-hand side.
On the right-hand side.
Yep, exactly. So if I were to use my tablet mode, so this is just me playing with my toys. So if I show you this, okay? So a number has a bunch of digits. Oh, why is this not working? Oh, it's offset just a little bit. All right. All right, so let's see if this works. Nope, nope. Okay, everything is offset a little bit. Darn it, doesn't work. All right, but I can still capture it. No worries. Okay, I can still capture this. All right, so if you look at the number, okay, so it has, D, I'm just using this as an example. So we have D2, D1, D0, and then the decimal point is always, to the right-hand side of D0, and then we have D, -1, D, -2, and so on. So that's how we find D -2. It is 2 places on the right-hand side of the point. And that is why the point is important, because the point is telling you where D0 is. So that gives you a reference point to find all of the other digits. Without that point, you will have no idea. Oh, we just see a whole bunch of digits, but which one is D0? We don't know, because we can have D negative. We can have negative positions. Is that okay? So let's go ahead and work with this. Okay, so we'll go ahead and do some calculations, and I will go carry out the calculations in Joplin as much as I can. So we will first, okay, so we have to apply this. What is this symbol? It looks like a little square bracket, but without the top of the square bracket.
Is it floor division?
It is what?
Is it floor division?
No, that notation is just floor.
Oh.
Yeah, it is just floor. It turns out that we are taking the floor of a division, but you can take the floor of anything. Yep. So I believe that is probably explained in the notes as well. So I'm going to try to find it. I'm just gonna be lazy and try to find, nope. Oh, okay. My computer doesn't like, I know why it's beeping like crazy, because it doesn't like this window. There we go. Sorry?
I don't think that's just a beep, that's a scream.
That's a scream, yes. Yep.
Really don't like it.
Yeah, it just doesn't like it when I have Zerno. I cannot put it on this side because if I put it on this side, I cannot use my tablet or my stylus on this screen. But when I put it on the other side, you cannot see it. So that's kind of the problem. Okay, fine. I'll figure out a way to get around this problem at some point. So for now, we're just not going to do it. All right, cool. So now we want to figure out the floor. So I'll just go ahead and say what the floor is. Okay, so we'll go ahead and say this is L floor, X right floor. Okay, is the largest integer that is less than or equal to X. That is how floor is defined. Okay. So based on this definition, let me check to see whether you understand the concepts or not. Okay, what is the floor of 2.5?
2.
Okay, it's 2 because 2 is the largest integer that is less than or equal to 2.5. Very good. What about the floor of 6? It'll be 6 by itself. Okay, fine. What about the floor of negative 1.5? Negative? No. It's negative 2. Very good. Because it has to be the largest integer that is less than or equal to x. Negative 2 is less than or equal to negative 1.5, but not negative 1. Is that okay? Now, so that's how floor works. So now that we know how floor works, now we can work out the rest, right? So we'll go ahead and substitute and figure out, what about this particular scenario? So what we're trying to figure out is, first of all, we divide 600.25, which is a base 10 number, by 9 raised to the power of negative 2. All right? So let's go ahead and do this. Instead of doing this by hand, I am going to use a spreadsheet to do it. And I'm just going to use LibreOffice on my computer, which is just a spreadsheet. You guys can use Excel or something like that. It doesn't really matter. Okay. All right, so let me move that window into your view, like so. Okay. Well, I'll just start a new sheet for this. Okay. So we have 600.25 as the number being converted. We have 9 as our base, and then we have negative 2 as the position of the digit that we want to work with. So the equation to do this is going to be the floor of, okay, we have the mod first. So we have a mod of the floor of this number, which is representing the value, divided by the base, oops, I need parentheses, the base raised to the power of the position, and that is the division. It is contained inside the floor, and then we have to mod it with the base one more time, and that is the answer. So one of the questions some of you may be having right now is, do I need to learn how to use a spreadsheet in this class? The answer is no, you do not have to. But is it going to be helpful for me to understand how to work with a spreadsheet? I would say definitely. Okay, so it's not a prerequisite of this class, nor is this class having an objective of teaching you guys how to use a spreadsheet, but it's a very useful tool to learn. Okay, so I'm just using this because it's a great tool. I'm feeling comfortable with this tool, and the answer is 2. What does that mean? What is that? What is this 2? How does it relate to what we are talking about? All it is saying, in this case, is if you go back to the original question, oh, not this one, I have to go back to Joplin. So if you go back to the original question, all it is saying is this digit here in base 10 in order to represent 600.25 as a base 10 number, but we want to represent this as a base 9 number. This digit is 2. That's all it is saying. What about the one next to it? What about d negative 1? Well, you have to reapply that equation. So now we go back to the equation again. And this is why I like to use a spreadsheet, because now, one thing I can do, this is not, the optimal way, but I can just change -2 to -1, and it turns out that digit is 2 as well. So that means if I go back to here, this digit, which is the one immediately to the right-hand side of the decimal point, is also another 2. What about D0? Tag, I bet you cannot figure out what D0 is going to be. It's easy. Just put a 0 here, and that turns out to be a 6. Do you see, how I can change I, which is controlling the position of the digit, and I can now figure out one digit at a time of the number in base 9 in order to represent a value that we know as 600.25. Question?
Do you think you can do it like by hand just to see like the steps?
Yeah, I can do it by hand, but the tool that I was planning to use didn't work well, so I'm going to have to use the whiteboard. Is that going to be okay with you guys? Use the whiteboard? Okay. So I would try to write it in a way that I don't have to go back and erase, so that way at the end of the class, if you guys want to come up here and take a cell phone picture of the whiteboard, you can. Just don't do it during the class, okay? So let me give it a try. So we have D equals to 600.25, and without any indicator here, it is in base 10. We have B, let's try base 7 this time, okay? So we're just changing the base, and then we'll try to figure out -3 or SI. I is -3. So that means if I look at the number in base 7, okay, I'm trying to figure out what this digit is supposed to be. Why that digit? Because D -3, or position -3, this is position -1, -2, -3. Because the decimal point is between position 0 and position -1. That is always the case. Is that good? Is that all right? Okay. All right, so now we just have to figure out the math. So we have 600.25 divided by 7 raised to the power of -3. We take the floor of that, and then we want the whole thing to be modded with 7. So here's 7. This is what we're trying to figure out. Is that okay? And obviously, this is not going to be an easy division, because first of all, we have to figure out what is 1 divided by 7 to the power of 3. That's going to be a little bit of a nasty math. So instead of doing that by hand, but is that helping? I mean, I'm just writing out, expanding the value, but to carry out the actual calculation, I would prefer to use a spreadsheet. Would that be, yep?
Isn't that 7 to the third power since it has a negative in the bottom?
It's 7 raised to the power of -3. That's exactly what you see is what we're trying to compute.
Oh, so you put 1 over 7 to the third?
It's the same thing.
Same thing?
Yep. It's algebra.
Oh yeah, but you have it there differently. Like it's 1 over 7 to the -3.
But do you know where we are in the notes?
Oh yeah.
Okay. So what is the problem?
No, I just figured out what,
Okay.
like I was thinking it.
Okay. Yep. Okay. So this is actually what we want to compute. So to do that calculation, I am going to use a spreadsheet. So that we're going back to the spreadsheet. We change the base from 9 to 7. And then we are changing the I, which is the position of the digit, to -3. And that turns out to be a 1. So now, going back to the whiteboard, now we can say, now we just figure out what that is. Yep.
So do we have to keep on going to the left and to the right until we get?
It's up to you. I mean, it depends on what the question is asking, right? So if the question is not asking about the entire number, and just asking about one digit, this is what you need to do. Now, on the other hand, if the question is asking about all the other digits, then this is not optimal, but you can do it this way. So you have -2, and digit -2 has a value of 5, so you put a 5 here. Whoops. And then let's see, what is the other one? -1, and it has a digit of 1, and so on. Now, unfortunately, in order to represent the quantity of 600.25 in base 7, it's going to be recurring on the fractional side. So it's just like 1 divided by 3 in base 10 is 0.33333 and so on. And in this case, it's just going to be recurring at a certain point. Okay, but for those of you who say, I'm not sure, this really doesn't look like it is 0.25. Right? Because in base 9, 0.151 is going to be approximately the same as 0.25 in base 10. It doesn't seem to make sense, right? So if it doesn't make sense to you, then we double check. So using the spreadsheet, now we just say 151, and this one is multiplied by 7 to the power of -1. And this one is, okay, so I'm just going to do a copy and paste. That's going to be -2, and copy and paste again. Oops. Okay, so copy and paste. This is going to be -3. And then we just add up these 3 cells and see whether it is coming close to 0.25. It should be somewhere around it, but not exactly. Aha! It sort of works out, right? So this is a quick way to kind of verify and confirm empirically whether the conversion is making sense or not. So are we good so far with that base conversion step? Because that's what lab is. Well, it's okay not to fully understand, because that's what your lab is about today. And the lab is intended so that you can, to figure out the answer of the lab, you just have to kind of go back to the material in the lecture, in your notes, and also in my written material, in order to figure out the answer. So it's a way to help you, make all the connections that you need in order to understand the concepts. All right. So let's move on. If there are no questions, if you guys do have questions, go ahead and ask. So what about binary numbers? Tack, forget about those really oddball, base, like base 7 and base 9. Who would use a base 7 number? We like base 2. So what about base 2 numbers? Well, that's easy. B equals to 2 for binary numbers. We have just, we started off with base 10 numbers, and then I generalized to any base, base B, and then now we are more specific to say, okay, what about base 2? Well, easy peasy. B equals to 2 is going to give you base 2 numbers. All right. And the next 2 sections are 7 and 8. Section 7 basically is just trying to emphasize why are we so interested in base 2? And it has to do with internal to a computer, everything is binary. So even though we are used to base 10 numbers, but because inside the computer everything is binary, it becomes really important for us to also understand how things are represented inside a computer. So that's the reason why binary numbers are really important. And then section 8 is basically just an exercise for those of you who want to gain a really good understanding of what this whole entire discussion is about, and you want to actually write a program in C++, Java, JavaScript, or whatever, just to confirm that your understanding of this material is okay, you can go ahead and write a program, okay? Write a program to do conversions, one way and then the opposite way. You can write a program where you give it an integer in base 10, it will convert it to whatever base you want to convert it to. And you can write another program where you give it a number in a specific base, and it will display the base 10 equivalence of that particular value. So do you have to do it? The answer is no. Would it be beneficial to do it? I think so. Okay? So if you have time, go ahead and do it. But if you do not have time, it's probably okay not to do it. So are we okay now with base conversion, and we can now get started with binary addition?
So are you gonna make this, calculate that by hand, or you're gonna let it use the computer?
You have a whole computer in front of you, so during the lab, use the computer.
No, but I mean like in exams or,
In an exam,
Yeah.
you would have your scientific calculator,
oh.
right? I mean, if you don't, I can go to the Dollar Tree and just buy a whole bunch of $1 scientific calculators as loaners. But until someone tell me I need a loaner, I'm not going to go buy those $1 scientific calculators.
To use these.
Absolutely, yeah. You can use whatever graphing calculator. I mean, just about any calculator would do. I mean, if your calculator doesn't have 7 to the power -3, what do? 1 divided by 7 divided by 7 divided by 7 gives you the same answer. Okay? Yep.
Go back to Excel. I want to see how you put in the Excel formula.
You mean the equations?
Yeah.
So you want, which one do you want?
Column A5.
A5. This one? That really is just the same thing as what we see here, except it has references to the cells instead, and also references to the formulae instead of the mathematical symbol. The other thing you can also do is to jot down the time, because this is all getting recorded. And I'll give you a link to the YouTube at the end of the lecture. So if you just kind of write down, it is 9:52 right now, you can quickly locate the spreadsheet, so you don't have to frantically try to write down the equation or the formula itself. Okay, are we good? Kind of? All right. So now we are transitioning to new material, which is also another reason why you might want to write it down, because we are starting on binary addition. I really doubt that we get to the binary part today, but I think we can go over the addition part. Right. So the overall organization of this entire module, and by the way, this is a long module. Okay. It can also be complex. So that's why reading ahead of time is really helpful. But the way I organize this is to introduce addition the way you know it already. So that means we're going to go back to this example here. So you guys can just focus on the right-hand side, and then I type on the left-hand side. So if I were to ask you, do you know how to add 784 to 217, what would be your answer? I certainly hope you guys would just go like, yeah, we can do it. What about without your calculator? Can you do this without your calculator? I'll give you time. Okay, you use scratch paper or whatnot. Do you know how to do it? So I'm not asking you to do it in 2 milliseconds. You can be given any amount of time, but I'm more concerned about, do you know the method of doing it? Okay, so I'm seeing a lot of people nodding their heads. So I'm going to make an assumption that everybody knows how to do this. Okay, it's not about the speed. It is about, do you know how to do it? All right. So the question now is, what do you think should go here? In other words, what is 4 plus 7? Some of you would say 11, but in a multi-digit addition, I would like to see it as 4 plus 7 is 1 with a carry of 1. Because in order to store a single digit as the end here, it can only go from 0 to 9, right? And 11 is more than 9, which means in order to represent 11, I, as a single digit, cannot do it. I need somebody's help. Whose help am I needing? The next digit. I'm going to tell the next digit and go like, hey, I'm supposed to represent a quantity of 11, but since I can only represent from 0 to 9, how about this? I will take the 1, you take the 10. That is the concept of carrying. Are we okay with the concept of carrying? When the single digit sum exceeds the base, or at least is as large as the base, then we have to have a carry of 1 so that the next or the more significant digit can take care of the excess of the amount. We good with that? Okay, very good. So at this point, I'm going to take roll first. Okay, so, because I need to make sure that everybody's here, and I don't want to do a roll call. So instead of doing that, I'm going to do the same thing as what we did last time. So I'm going to change one of these to today's date and then give you guys the answer. So today is 09/2/30. Okay, it's the 30th already. And the roll-taking word is logisim. I'll write it on the whiteboard so we don't forget. Okay, so we have logisim as the roll-taking word. I'm not going to change that. And I'll give you guys plenty of time to do it, including part of the lab time. The lab time officially starts at 10:30, so I'll give you up to like 10:40. I mean, I recommend that you do it now before you forget, but you can have up to 10:40 to participate in this quote-unquote activity to take roll.
And the thing is Logisim?
Yep. So there we go. As I said, if you do it now, it's probably better, but you can do it later if you want to. I'm just going to move it to the right position just so that it's easier to find. There we go. Now it's at the right place. And today is technically the 3rd class meeting, so anyone missing today's class alone by itself is already qualifying to be dropped from the class. All right, so as you guys are entering all that stuff, I'm going to go back here. And so I'm going to put in the answers to the example. So we'll go ahead and copy and paste it. There we go. All right. So what should go here is going to be a 1 because 4 plus 7 is 1 with a carry of 1. Now I know this is not how you were taught to represent where to put the carry and stuff like that, but I really want the carry to have its own role because that makes it easier for me to explain the structure of addition, multi-digit addition. All right, what about 8 plus 1? What about 8 plus 1? What should I put here as the single digit sum of 8 plus 1? That's just 9. Okay, very good. 9 does not end up with it does not result in a carry. That's okay. What about 9 plus 1? What should I put here? It'll be a 0 with a carry of 1. Very good. So there's a 0 and there's a carry of 1. And what should go here? 7 plus 2 is also a 9. And then 9 plus this one is going to be a 0. And we have final carry of 1. And I did not leave enough space to do it, so I'm going to have to shift everything by 2. So I have the place to put this extra 1. So let me finish the reformatting. Nope, it's still not. Oh, I see. There we go. All right, so we just have this one more thing to deal with. 1 plus 0 is a 1. Okay? And then someone's going to say, but don't you really mean your 1001? Well, no. I really do mean, I really just mean 001 with a carry of 1. Why? Because if you are adding stuff inside the computer, the number of digits cannot change. If you are given 3 digits to start with, the sum can only be contained within 3 digits. But you do have an overall carry of 1. So what do you think this overall carry of 1 is representing? It's representing 1,000. Okay? Because with 3 digits, I cannot represent anything, I can only represent values up to 999. So when the value is exceeding 999, then I need this overall carry to say, there's an amount that I cannot represent using these digits, and it turns out to be 1,000 in this case. All right. Okay. So are we feeling okay with this notation? All right. So now I'm going to start to name the rows and the columns. This row I would call it X. This row I'm going to call it Y. This row I will call it Q. This row I will call it K. And this row I'm going to call it S. And in addition, I will also have named the columns. So the columns would be column 2, column 1, and then column 0. And they are not exactly at the right place. There we go. Now everything lines up. So that's basically our I. It's the position of the column. So are we doing okay so far with this notation? This is row X, row Y, row Q, row K, and row S. Column 0, column 1, and column 2. The columns are just corresponding to the positioning of the digits. We doing okay? All right. And now I will start to introduce the concept of a single digit sum. So I'm going to say single digit sum of 2 digits is the value that can be represented using a single digit after adding 2 digits. Okay, so give you some examples. So if R of xy is the single digit sum of x and y in base 10 right now, okay? Then what is R of 4, 7? If I'm adding 4 and 7, each one being a single digit in base 10, and I only want to know the sum that is representable using a single digit, and the other part can be done with a carry, what would be the answer?
1 with a carry of 1.
It's just 1, without the carry of 1, because the single digit sum is just only focusing on the 1 digit as the sum. Okay? I'll give you a chance to answer the additional questions. Yeah, go ahead.
So this is addition in base 9, right?
Yeah, this is all in base 9 for now.
Okay.
For now.
Yeah.
What about this? What about if I add 7 and 8, and I look at the sum and go like, okay, I think the carry can deal with something, but what is the single digit of the sum? 5, exactly. So I'll give you guys one more example, and then we can move on. What about this in base 10? If I were to add 5 and 5, what is the single digit sum of that addition?
0.
It would be 0, exactly. Okay, very good. And then one more, okay, just simple one like that. That would be 5. Okay, very good. Okay, so now we have another function, c of xy is the carry of adding x and y. X is a single digit, so is y. Okay, so we're going to use exactly the same examples up here, just to make sure that we understand what it is representing, and then we'll focus on the code to do it. And so I'm going to erase all the answers because they're all wrong. There we go. What is the carry of 4 plus 7 in base 10?
1. 1.
Yes, correct. And the carry of 7 plus 8? 1. The carry of 5 plus 5?
1.
And the carry of 2 plus 3? 0. Very good. Okay, so I think we understand the concept of what R and C are trying to do. So the next thing we need to do is to figure out, but how do we do that, right? In C or C++? Well, Well, fortunately, that part is already done for you. So if I go back to the notes, which is module 283, this is how we do it. Okay, so the C function, or the function C, is really just saying, okay, if x plus y is greater than or equal to 10, give me a 1, otherwise give me a 0. If this particular expression looks foreign to you, that means your C++ professor did not teach you the ternary expression or operator. So how many people want me to kind of explain the ternary operator? Okay, that's fine. Let's do that. And I will try to do it the lazy way first and then go back to the harder way. Okay, the lazy way is just to say ternary operator. And with a single click, there we have it. The harder way is for me to actually explain it. So we'll do it the harder way now. But I want to show you Google because what if I'm not around? What if you guys are studying and you encounter a concept and go like, I'm not sure what that is. Okay? If you know the name, you can find it. Let's say you don't know what is the ternary operator. How would you use Google search to find it? You encounter this expression and you have no idea what the question mark or the colon is doing in this particular expression in C++. So how would you go to Google? Because you don't know the name. You don't know it is called the ternary operator. So not knowing that this is called the ternary operator, how would you search it? How can you Google search it?
Copy and paste, right?
You could do that, or you can say, C++ expression question mark colon. I'll bet you the first 3 links will be relevant links already. So it's really important that you guys also understand that sometimes it's useful for you to go out and actually search for the definition instead of going like, I've never seen this before, I've got to stop here. Okay? Do not let it stop you. Try to look for the answers using all the tools available. All right, so now that we know it's called a ternary operator, what does it do? It has 3 parts. Why do we know a ternary operator has 3 parts? Okay, there's unary, which means 1. There's binary, it means 2. What do you think ternary means? 3. Yep, exactly. So it has 3 parts. This is the first part, this is the second part, this is the third part. But what does it do? I mean, there are 3 things, so what? The first part is a condition, just like the condition of an if statement, okay? It is a condition. It is returning either true or false. If the first part returns true, then the second part becomes the value of the entire expression. On the other hand, if the first part evaluates to false, then the third part becomes the value of the entire expression. In other words, it is a conditional statement in a single expression, in a single, using a single operator. It is literally, if this, then this, else that. Yep.
Does Java have like something similar to that?
Oh yeah, everything that is C derived has it. So Java has it, JavaScript has it. Let's see, I think Visual Basic has something similar. Spreadsheets has something like that. Python has it, even though the ordering is a little bit off. They like to express the then value and then the condition and then the else value. But almost every single programming language has a construct like this. Okay? All right. So given that is the case, some people may still be asking, but why do you need to do this? Why don't we just kind of return this and we're done with it, right? Because all we need to know is whether x plus y is greater than or equal to 10. So why do we need a ternary operator to force it to return a 1 or a 0? Doesn't it automatically return a true or a false already? Well, that's a tricky question, because the first part of that answer is yes. X plus y is greater than or equal to 10 returns a Boolean, a true or false already. So that part is true. But the second part is, what exactly is true? Is true the same as the value of 1 or not? So that particular question is a tricky one, because how is true represented in C++. Yep.
False is 0, anything else is true.
False is 0, that is correct. And then
Anything else is
anything else is true. Very good. So if the type is an unsigned instead of a bool, that means 1 is interpreted as true, so is 2, so is 3, so is 4, so is 5, and so on. So if I forget about the ternary operator and just say return x plus y is greater than or equal to 10, there's no guarantee that it's going to return a 1 if the condition is true. It can return some really random number like 619. Anything non-zero is true. So if I really want the carry to be a 1 or a 0, I need the ternary operator to force it into just 1 or 0. Are we good? Are we doing okay so far with that? Okay.
It might just cause a headache for you later on because you're like using that function and it's
Yep.
returning some BS value. That's
Oh, the
positive.
worst part is it depends on the compiler. So if you're using GCC, maybe GCC is just be consistent and go like, oh, every time there's something true, I'm going to give you a value of 1, otherwise I give you a value of 0. And then you try to recompile the same code in a different compiler. That other compiler may go like, hey, according to the ANSI standard, anything non-zero is true, so it can just give you anything. It can give you like the maximum, the largest unsigned value, and go like, okay, that should be enough ones in this binary representation to convince you that it is true. So a program that compiles and runs really well with one compiler because of the unfounded assumption can behave entirely different in using a different compiler. So now you have a problem because it's hard to troubleshoot and find out why the program is not working anymore.
And then you spend like 2 weeks looking for this and it's something stupid like forgetting a ternary operator.
Something that can be saved by a ternary operator. All right, so what about R? R is also simple to figure out. It is simply x plus y, which are the my parameters. The whole thing mod 10. Why mod 10?
You're in base 10.
You're using base 10, right? So are we doing okay so far, making all the connections between the example, which is in Joplin, where is it? There you go. So are we relating everything that we see in the example right here, and also the definition in C++, only for base 10. So right now we're only working with base 10. Are we doing okay? All right. We do have 5 more minutes left, which is enough time for me to show you the quote-unquote structure. So now I look at this addition here and go like, well, this is a concrete example, but can I figure out the relationships between the digits? In other words, x and y are given. Okay, so those are given to you. Don't ask me why they have the value that they are. So because they're given to you. Q0 is not Q0, but K0 is also given. Assume it is given to you as a 0. So we need to figure out Q, K, and S. That's what we're trying to figure out. So if I want to ask you, okay, we'll start with a particular abstraction, Q of I. Okay, what do you think is Q of I using the definitions that we have just looked at? What is Q of I? Now this I here is just a placeholder of the position. Yep.
It's that whole row of cubes.
Well, Q of I is just one single one. Okay, let's just focus on one. What is Q of 1? Right, so it makes use of xi, yi, right? So Q of 1 is the R, the single digit sum of x1, y1. So if we generalize this one more time, it is Q of I equals to R of xi, yi. Is that okay? Because that's exactly how we got the 1 under, on this side. That's how we got the 1 under the 4, 7. Because 4 plus 7 has a single digit sum of 1. It's also why we got a 9 under 8 and 1, because 8 plus 1 has a single digit sum of 9. 7 plus 2, same thing, has a single digit sum of 9 as well. So the entire row Q is simply the R result of the corresponding X and Y digits. So this is what I meant when I said structure, because by a single definition of Qi equals to R of Xi, Yi, I have just shown you how to compute everything on the R row. Are we good are we okay so far? Okay. So the next one up is, what about the K's? Okay, this one is a little bit more complex. So K of I plus 1, in other words, it's off by 1, because in order to determine a K digit, you have to look back to the less significant column, because that's the contributing column. So in this case, okay, I'm going to scroll down a little bit because I'm short and I want to point to the thing. So this one here, how do I got this one?
The previous one.
The previous one, but can someone spell out the actual addition that resulted in a carry of 1? Yes?
X0 plus Y0.
Exactly. So x0 being 4, y0 being 7, 4 plus 7 ends up with a carry of 1. Okay, so we now know that the xy can contribute a 1 for the carry bit, right? But is that the only reason? Is that the only source of a carry of 1? No, because look at this one here. So look at K2. K2 is a 1, not because x1 plus y1 has a carry. It has to do with Q1 plus K1 having a carry. So we know that there are two sources to result in a carry of 1. One is coming from the addition of the xy. The other one is coming from the addition of the qk. We doing okay so far? So now, when I'm trying to figure this out, I'm just going to say, okay, so knowing this part here, we know ki plus 1 has something to do with c of xi, yi. It also has something to do with c of qi, ki. So the question is, how do I connect these two carries? Because from the example, we can see that sometimes it comes from c of xi, yi, and some other time it comes from the addition of qi, ki. So what do I need to do? What operator do I need to use at the blinky cursor to say, okay, this is how we combine c of xi, yi and the c of qi, ki in order to figure out k of I plus 1? There's a very obvious answer. Okay, go ahead and we'll go with the obvious answer first. What operator can go here so that it would still give us the right answer?
Addition.
Go ahead. Addition. Okay, so we can use addition, and that works. Okay. But if you use addition, it seems to imply that some people are thinking there are certain situations where c of xi, yi and c of qi, ki can both be 1s. Then you end up with a 2 as a carry. Have you guys ever encountered a case in multi-digit addition where the carry is 2? Never, right?
Because it made sense, since like 9 plus 9 would be 18. So even
Right.
then, only the carrier would be 1.
Yep, exactly. So those two cannot be 1s at the same time. I think I'm going to defer the rationale, the explanation to the next class, but you are absolutely right. Okay, that's exactly why. But I'm going to lay out the actual detail of the reasoning in the following class. But the idea is, no, c of xi, yi and c of qi, ki cannot be 1s at the same time. So if they cannot be 1s at the same time, what other operator can get this done? And it translates to transistors.
Yeah.
Or, just a regular or. So we can actually change this to a regular or without using addition. I like this because any chance I can get to use operators that can translate to transistors, I will take that. Okay. But you guys are all saying, but tag, there are a lot of things we cannot convert, to transistors just yet, because some of you are going to point out and say, even though we can convert that plus to an or because of the two carriers cannot be 1s at the same time, What about this plus here? What about this plus here? Those cannot be translated into transistors, right? Because they're not logical operations. Well, that's because we're dealing with base 10. Looking at R and C as they're defined now, what do you think you need to change to make them work for binary numbers? Yes.
Change the 10 to a 2.
Woohoo! Yes. Isn't that easy? This is the way I try to introduce the material. We start with base 10, a concrete example of base 10 addition, and then I abstract it to extract the structure of how it is done, digit by digit, how the digits relate to each other, right? And then I define the R and the C function to get the job done. And then we look at the R and the C function, which are the only thing that has any reference to the base that we are using, which is base 10. And we go like, hey, if I want to convert everything to base 2, that's all we need to do. Change all the 10s to 2s and we are done. Okay? And someone's going to still complain and go like, but that doesn't solve the problem. We still have the addition. Even though x itself is a 1 or a 0, y itself is a 1 or 0 because they're binary now, we still have the addition here and we still have addition here. And look at this. This is ugly because it's a mod, which implies a division. So next time on Thursday, we'll take a look at what happens when the 10s turn into 2s, and you go like, oh, so that is really cool. Because it is really cool, because when you turn the 10 into 2s, you can actually use logical operators to get everything done. So that's the trajectory of this class, starting with concrete examples that we all understand, abstraction, okay, to the structure, but it's still specific to base 10, and then abstraction to any base, and then refocus or specify to base 2, and then because base 2 is a specific case, which allows us to use binary operators or logical operators, that's how we're going to solve this problem. Okay? So read ahead of me. I know the next, we have a lab time next, but read ahead of me. This is a really long module, so however much you can read ahead of me, ahead of the lecture, is going to be beneficial because these are all kind of important stuff. And number 2, write down the definitions, okay? Because you are going to need it. From past semesters, years and years of past semesters, I know that people who do not write down the definitions and have it well organized within your notes, they have problems later on in the exams and so on. So you probably want to kind of organize your stuff, make sure you can find the definitions. What definitions are we talking about? Definitions like, how Q relates to X and Y, how R and C are defined, and so on. I mean, all of these are already in the notes. All you have to do is to figure out how you want to organize these definitions in your notes so that you can find your stuff in your notes. All right? So I'm going to give you guys a break, like let's say 10-minute break, and I'm going to start the lab, at about 35. I mean, I'll start it soon, but you don't have to come back until like 35. And then I'll give you 5 extra minutes, which means the lab is going to end at 11:55. So everything is just shifted by 5 minutes. All right, so take a break. I'm going to set up the lab.